Hello viewers, in today's class we are going to solve one important indefinite integral, and here we have to solve this indefinite integral, and let us call this integral as I. Right now, before proceeding further, we have to closely inspect the integrand, right? And we have to identify the form by which we can easily solve the indefinite integral, right? So here we see that in the denominator we have x, right? And here we have log x square, and here also we have log x. So this expression is a quadratic expression in log x, right? So if we take say t is equal to log x, right? And let us see that how we can transform this equation, this integral, by making this substitution, right? So we'll take t is equal to log x. So therefore dt over dx is equal to 1 over x, right? And dt can be written as dx over x, right? So here we see that this term dx over x can now be replaced by dt. So now our integral, it can be taken as, or it can be rewritten as dt over 6 log x square. Log x is t, so we have 6t square plus 7 log x. Log x is t, so we have 7t and plus 2, right? So now we see that the given indefinite integral is now reduced to this form, and this denominator is a quadratic polynomial, right? So this is a quadratic polynomial, and what we do in such situations, we have to make a perfect square, right? So we can convert this quadratic polynomial into a perfect square by taking 6 common, right? So what we will do, we'll take 6 common, so we have 6, and here we have t square plus 7 over 6 t plus 2 over 6, right? Now let us concentrate on this term, that is t square plus 7 over 6t plus 2 over 6, right? And here we have this term as a square, that is this term is a square, and this term is 2ab, right? So what we will do, we have to add b square, and then we have to subtract b square, right? So what we will do, we'll write this term as t plus, here we can write 7 over 12 whole square, right? Because this is t square, then we have 2ab term, that is 2 times t times 7 over 12, and this is 2 6 are 12, so we'll have 70 over 6, and which is this term 70 over 6, right? So t plus 7 over 12 square, and then we'll subtract the square of 7 over 12, right? And here we have the term 2 over 6, right? So now we can simplify this term. So we have t plus 7 over 12 square, and this term is 49 over 144, and this is 1 over 3, right? Now if we simplify these two terms, we'll get t plus 7 over 12 whole square, and here we can take the LCM as 144, so this is minus 49 plus, and here we have 3 4s are 12 and 3 8s are 24, so minus 49 plus 48. So now this expression can be written as t plus 7 over 12 square, and here we have 48 minus 49 is minus 1 over 144, and this can further be written as t plus 7 over 12 square, and 1 over 144 can be written as 1 over 12 square, right? So here's this quadratic polynomial can now be replaced by this one, right? So now I can be written as this 6 can be taken outside the integral, and we have dt, and then we have t plus 7 over 12 square minus 1 over 12 square, right? So now let us substitute here y is equal to t plus 7 over 12, right? So now dy is simply equal to dt, and now this integral I can be written as 1 over 6, and we have dy for this dt, and for t plus 7 over 12 we can write y, so we have y square minus 1 over 12 square, right? So now we see that this form is similar to this form, that is dx over x square minus a square, right? So what we have done here, we were given this integral, we have taken t is equal to log x, then we have transformed this integral to this one, and then we have converted this quadratic polynomial in terms of the perfect square, and then by making this substitution we have reduced this integral into this form, that is dx over x square minus a square, and here for x we have y, and for a we have 1 over 12, right? And we know that the integral of 1 over x square minus a square is given by 1 over 2a, and log of we have x minus a over x plus a, right? So now we can write I as here we have 1 over 6, and this integral can be written as 1 over 2a, and for a we have 1 over 12, and then we have log of x minus a. So for x we have y, and for a we have 1 over 12. So we have y minus 1 over 12 over y plus 1 over 12, right? And c is the constant of integration, right? So now I is equal to, here 6 2s are 12, so these two terms get cancelled, and we are left with the log of y minus 1 over 12 over y plus 1 over 12, and here we have c, right? Now we can resubstitute, or we can replace y by t plus 7 over 12. So we have here t plus 7 over 12, then here we have minus 1 over 12, here we have t plus 7 over 12 plus 1 over 12, right? Okay, so now we can further simplify it. So we have log of t, and here we have 7 minus 1, that is 6 over 12, and then we have here t plus 8 over 12, right? And now we can write it as log, this is t plus half, and this is t plus 4 2s are and 4 3s are, and now t can be replaced by log x, because initially we have assumed t is equal to log x, so we have log of log x plus half, and here we have log x plus 2 over 3 plus c, right? and now we can simplify it. So we have log, and here we have 2 log x plus 1 over 2, and here we have 3 log x plus 2 over 3, right? And here we have the constant of integration. So now I can be further written as log of 2 log x plus 1 over 3 log x plus 2, and these two terms, this 3 will go to the numerator, and we have 3 over 2, right? And by the properties of log mn is equal to log m plus log n. So here we have, this is one term and this is the second one. So now I can be written as log of 2 log x plus 1 over 3 log x plus 2, and plus log of 3 over 2, right? And c is the constant of integration. Now log of 3 over 2 is again a constant, and constant plus constant can be replaced by another constant. So I can finally be written as log of 2 log x plus 1 over 3 log x plus 2 plus c1, right? And c1 is some other constant, so c1 can be taken as log of 3 over 2 plus c, right? So this is the integral of this given function, that is 1 over x times 6 log x square plus 7 log x plus 2, right?